This conference will now be recorded.
Okay, we've got the slides in place.
Yes, so
thanks very much.
I was just trying to share, Darrel, the presentation.
Are we okay? Good to go?
Yes.
Okay, thanks everybody. My name is Darrel Tiddy. We're going to co-host. I'm going to co-host a presentation with Elena Ionescu today regarding network rail and overhead line maintenance on the Wales and Western region. I'm proud to say I'm a member of the PWI and have been for the last 20 years. Even though I work on the overhead line, I never really forget where I started in Nottingham and Derby and the East Midlands some 25 years ago. So we're going to take a look at the overhead line. You can see that in the picture, it's fully in construction and lots of ladders in use. So the photograph on the far right is circa 100 years old. So we'll put that one up just as an opening slide, but to remind us that a couple of things: overhead line isn't new, and secondly, it's got lots of bits and pieces, and it can be a challenge to maintain. Next slide, please. Okay, thanks very much. So a little bit of an overview of the presentation. As we've got myself and Elena. Elena's background is overhead line design with one of the engineering consultancies, and my background is permanent way maintenance, permanent way asset management, and overhead line. So a little bit of a jack of all trades. I'm trying to be a master of one at least. Okay, so then we're going to take a look perhaps a refresher about the electrification program in the Wales and Western. Elena's going to run through the different types of OLE systems we've got on the route. There are some subtle differences as to why the new Series 1 system is sort of superior to the conventional arrangement. Elena will then look at the railway as a system, and being a P-way engineer, not managing overhead line originally, we plonk overhead line on top, and it makes it a bit more challenging. Pantograph types in use on Wales and Western. There are different pantographs. Not all pantographs are the same. Then we're going to look at briefly the challenge of overhead line maintenance and how we get from having no staff to a full complement. Things do go wrong, so we'll take a look at those. Then we're going to look at some new technology and some technology we're going to look at which we're going to implement on the route over the coming 12 months. So you can see the picture on the right, which is a bit of a hybrid photograph, which I've doctored. You can see, for want of a better word, we've got a pendulum and a man in the basket. The pendulum has shifted firmly towards maintenance. For several years it was sat with the project, so working in asset management and supporting maintenance. The pendulum is firmly across into overhead line maintenance. Okay, thank you, Elena.
Okay, good afternoon, everyone. Thank you for being here today. My name is Elena Ionescu, and I work for Network Rail as an asset engineer, OLE support. And today I'm going to start my part of presentation by giving you a little bit of background on Great Western Electrification program. So for the just give me a second, please. GWEP is the biggest investment in the Great Western Railway since Brunel built it more than 150 years ago. Modernizing the route improved the experience of everyone who uses it, and of course stimulate the economic growth in the southwest and beyond. So this huge project saw 22,000 OLE support structures installed, approximately 1,000 kilometers of wiring, and 160 bridges have been modified or replaced along the way. And of course, there are works like resignaling and new rolling stock and station upgrades. And so as well, to save the time and money, the project team developed, especially for GWEP, a new high output construction trains, just to make the installation of the piles and the mast much easier than using the traditional methods. So for the introduction of the intercity express trains, as I said before, 1,000 kilometers of railway was electrified between London and Cardiff. And under the intercity express program, there are about 57 electric class 800 series trains were ordered as replacement for the old intercity 125 diesel. But unfortunately, because of the delays in this modernization project, it was confirmed that the new trains will be converted to bi-mode, which means they will run on diesel and as well on electric overhead wire. So in this slide, you can see all the entry dates, so entry into service dates for Great Western electrification. And as you can see, we have the legacy OLE from Paddington to Heathrow since 1997, and we've got to Cardiff, so as far as Cardiff by January 2020. But this is coming with a number of challenges, and for us, we had to have all the delivery units on Wales and Western. They have to be up and running. So what I'm going to do now, I'm going to try to give you an overview on the different system we are using now on GWEP. So the Series 1 is the new overhead line equipment which was implemented on Great Western Railway. And this equipment is a modern, lightweight with auto-tension system for operation for trains with a speed up to 140 miles per hour, and as well with the multiple pantographs. And this system is coming with a number of benefits, which is they have the single insulator cantilever, has a reduced number of components. That's for like simply to hook on the pre-installed attachment on the mast. The two-track cantilever used with booms for it's like a quick lift and just land installation. It uses monoboom anchors for easy wiring, and we have single span overlaps for efficient use of the tension length. So in the pictures, you can see a traditional cantilever shown on the left, and you can see a large electrically live envelope, which is like difficult to construct to do the use of like having like sloping tubes, and this comparing to Series 1, which is the picture at the right, and which is like a Series 1 cantilever developed with a much smaller electrical envelope, and it's like a rapid adjustment mechanism so that construction time is minimized, and of course the staff safety was maximized. In here I have, I just want to talk a little bit on the Headspans, which we have, which is a Mark IIIB OLE equipment. So from actually at the moment in Western, we have from Paddington to Stockley Junction, we have those Headspans, which are, I could say, an equivalent of the portal arrangements from Series 1. So this type of structure, it's, as you can see in the picture, is consists of a system of wires spanning between masts. So it's either side of the truck to support the OLE. So it's like in practice, those headspans represent a great risk for us because of the lack of the mechanical independence between the registrations. Excuse me. Which means in case we have a derailment, the impact is going to be significant and is actually affect multiple trucks, which is going to increase the time to reinstate the equipment. So as a consequence of that, headspans now are avoided, but we still have those ones in it's like historic train sheds. That's because of the slow speed trains, which actually they are like they have like a reduced risk of damage. A little bit of Series 1 tensioning system versus traditional tensioning systems. You can see the picture at the bottom, the traditional balance weight anchor, and at the top you will see a Tensor XC Plus on a monoboom anchor, which is part of Series 1 equipment. So the balance weight system will apply tension to catenary system while allowing for any movement due to the expansion of or contraction of the wires because of the temperature and weather and so on. And so the concept on the wall system is to use a simple pulley system to amplify the tension imparted by the vertical hanging weights, as you can see in the picture. But they have like a number of disadvantages, which they need to be inspected very often. It's like in regular patrols, and they have pulleys which they can seize. So comparing to the wall system, the new Tensor XC Plus is coming with a number of advantages as well. So the Series 1, the contact and the catenary wire are independently tensioned using this Tensor X, and they are normally arranged on a monoboom anchor structure, as you can see in the picture. And comparing to the conventional wheel tensioning equipment, this Tensor XC has a compact design and a low overall weight. So as you can see, there is no concrete or like steel weights are required. And so you can see on the slide a number of other advantages as well. This is like a typical two-track single-span overlap, which we have in Series 1. The top picture, you can see the Tensor X's on the left and on the side for which are used for terminating the wires. I'm going to talk a little bit on support and registration. So where there are only two tracks, OLE normally is going to be supported from line side mast using cantilevers. Those cantilevers, they are coming with a number of advantages. It's easy to adjust and they are cheap, and these are the preferred option for us. So this is what we call single track cantilever. In here, it's the same single track cantilever as you could see in the previous slide. So for minimizing the wear of the system and to allow the power to flow uninterrupted to the train, for us the contact wire has to be kept as stationary as possible. And we are having this type of for this type of structures. It will be easier to do any adjustments, as I said, in case the track design is changing, because everything is related to the track. So as an example, if we have any track lift, if the track is going to be lifted or is going to be lowered, that is going to have an impact on contact wire height, which is going to be adjusted by just sliding up or down the arrangement on the mast, or as you can see in here, or if we have a stagger correction, the registration arm will slide along the cantilever tube, but there are some other adjustments as well. So it's very simple to work with those with this type of equipment. So if we have multiple track areas, we will be using a TTC, which is a twin track cantilever. So it's going to carry two sets of catenary from one cantilever boom, and in front, it's like on the picture, the bottom picture, you can see the TTC on the left. It's a long reach TTC, and the other one is just a normal one. This is so where there are more than two tracks and the cantilever masts are not feasible anymore, then we will need a steel frame spanning the tracks, and this is generally referred to a portal frame. This is what you can see in the picture. So in the picture at the front, you can see a typical monoboom anchor portal, and at the back is going to be a normal portal arrangement. And as you can see in the right hand side, sorry, is the structures placed. They are placed approximately every 50-60 meters to keep the electrified wires running between them and under the correct tension for the trains to pass safely. And now I'm going to talk a little bit about the railway as a system. So as you can guess, it's like by electrifying the route, the interface management has changed. So we don't have only like an interface management between the track, the wheels, and the rolling stock. Now we are going to have as like an interface to manage between the rolling stock, which is the pantograph, and the new electrification. So for us, the pan wire position is critical. So there are a number of factors which needs to be considered. As you can see, this what is pointed here, A, B, and C, is going to be clearance between vehicle and the contact wire, and then between the pantograph and the structure, and then it's going to be between OLE and the structure. Otherwise, we are getting what we call like trippings and some other problems. So from design point of view, on the top part of this picture is like the designer is going to consider the uplift, the OLE tolerances, and the construction depth, and at the bottom allow track tolerances installation, and if there is any lifts, so for like lift allowance and potentially track lowering. On this slide, it's you can see how much the OLE is affected by any changes in track design. So if we are lowering or lifting the track, that's going to be an effect on the contact wire height. And if there is any slew or cant adjustments, that's going to have an effect on stagger. So as you can see, 1 millimeter change of track is going to affect, it's like it's going to bring 3 millimeters change on the OLE registration position. And now I'm going to hand back to Darrel.
Thank you very much, Elena. Thank you. Okay, we've taken a look at briefly different types of pantographs. Okay, next slide, please. Okay, obviously my background is track, so when I came across to a Redline, one pantograph looked the same as another. It's a mechanism stuck up into the air to collect the current and slide it across the contact wire, off we go. But there's a bit more to it than that. As you can see on the slide, we've got several operators in the mix with several different types of trains. Most use different pantographs, and they're different train manufacturers. So we have a relationship with each operator. We have an understanding of what pantographs we use. They behave different dynamically at different speeds, and the pantograph technology is very much an evolution. So if we look at the 769s with the HSA, which is the old Apex train, was knocking around in the 1980s when the 769 were built. They've recently been refurbished and will run on the north and south bands. Okay, so you can see we've got quite a few interfaces with the talks, and we need to have an understanding of what pantographs we use, and we'll take a look at some of those on the next slide, please. Okay, so if you look at the photograph on the left, we've got what we call a lateral sprung arrangement. You can just see at the top of the central horn, you've got these sort of horizontal lateral springs, and you've got what we call a fixed stub horn, which allows the contact collectors to effectively float. It's a very lightweight head. We want it to be, pantograph heads need to be light, so they don't really bounce off the contact wire. And we run with a 90-meter contact force to give you the uplift and to get a good fit as we slide along the overhead line. The aerofoils on this particular configuration are based down on the knuckle and can run up to sort of 125 in multiple configurations, with potential for 140 on Series 1. You can see this is what we call an open horn arrangement. Just go off the slides. We've got what we call an open horn arrangement, and when we look at the next slide in a few seconds, you'll see it on the photograph on the right hand side. You'll see what we call a closed horn arrangement. The reason the horns have changed by design is to make the IT pan a lighter arrangement, which is similar to the configuration to the pregnant waist pantograph you can see on the left photograph, which again is the same sort of open horn arrangement. But you can see that the mechanism, although the photograph isn't very good, that's called HSP Mark II, which is a plunger spring. So it behaves slightly different dynamically, but that can run in multiple configurations up to 110 miles an hour thereabouts. So there are differences, which I certainly wasn't aware of when I sort of transitioned from PUA onto overhead line and pantograph. So they tend to evolve to make them better perform, because what we need is a nice, good, consistent contact force on the contact wire. And bearing in mind, the pantograph does a lot of work. As the train goes along the track, the contact wire, whilst we have a nominal contact wire of 4.7 meters, the pantograph literally ducks and dives as it goes through bridges. It comes down to get through a bridge and then back up. And as we approach level crossings, the pan goes up to sort of 5.5 meters. So the whole mechanism does a huge amount of work. It doesn't look like it does, but when you watch it on a pantograph camera and video, which most of the fleets have now, so we're able to replay an incident. Should we have an incident, we can replay that incident and see what went wrong, and also we can look at from an inspection point of view. It's quite useful to look at the overhead line from the position of the contact wire, so we can look at the pan cam and make a judgment. Next slide, please. Okay, thanks. Next slide, please, Elena.
So it's something is just saying screen sharing is now paused. I don't know why. If someone
Elena,
from
at the
yes.
top of your screen, if you move your cursor to the top of the screen, you'll see a little triangle which says play, and then or two little dashes which is pause. So you need to click on play. There we go. It's back now. You're sharing again. So
Okay, thank you.
all right, thank you.
Thanks very much. Okay, so when things go wrong, which they do, we've got a mechanism stuck up into the air. If something goes wrong, we need it to come down very quickly, so it'll prevent further damage to the infrastructure. So there's two photographs we can see. The photograph on the left is where we have a very worn carbon, and it's gone beyond its wear limit, and it's inside the pantograph carbon carrier. It's pressurized, and if it's damaged or the carbon becomes worn, it'll lose pressure and drop automatically. So they call it ADD. So if we have an ADD on the network, something's gone wrong, we've either got a very worn carbon, which in the early days, carbons used to wear out like people used to wear their socks out. And with installing new contact wire, you can imagine that the profile of the contact wire is circular, and that once it gets a little bit of wear, you have a very narrow flat, which reduces the friction on the carbon strip, and also the carbon is a metallized carbon, and you get some carbon embedment in the contact wire. So the contact wire is quite crude when you went to train into service on a new network. So we did win the prize for using all GWR carbons on the 387. So we actually ran out of carbons. We had plenty of trains, but we have run out of carbons. So the pantograph carbon life has it changes after entry into service, and it gradually goes up, and now we're getting very, very good carbon life. So, but if carbon aren't managed, it's no different to having brake pads on your car. Eventually, you go down to the metal. This is the same. If we go down too far, we activate the ADD. Pantograph will drop, but unfortunately, then we're stuck with a stranded train. So the train operating companies are really good at managing within their limits. This was early days when this photograph was taken, and it caught a few people out by surprise. The photograph on the right was an incident we had back in June over at South and West, was where there was an inline component which had become detached. And we'll come back to that in a few minutes. That had become detached and rattled loose. Pantograph comes along, it's hanging below where it should be, and there's an immediate impact. You can see the pantograph is catastrophic damage. This was the leading pantograph. The rear pantograph managed to straddle through and believe it or not, make it home. But in the meantime, leave quite a bit of damage behind. Okay, next slide, please. Redline maintenance. Thanks very much, Elena. Okay, thank you. So, as we spoke earlier on about the completion of the project, and it's been very much progression from Stockley Junction near Heathrow all the way down to Cardiff. That's been in stages, as we've spoken about earlier on, and the challenge has been to really meet the handover to the project. The construction has been completed, and we're in the phase of formal handover, but we've been running trains for quite a few years now. So we've got the existing depot, Westbourne Park, a new depot, which is the Eastern Delivery Unit at Reading. As you can see there, Bristol and Swindon, and then a team based down in Newport at the Cardiff Delivery Unit. And the challenge has been really to bring in new staff and to get them suitably trained up in what has been a relatively short space of time, given it started from new staff. There aren't many in the south of the country. Linesmen and women aren't easy to come by, and I think quite often they stick with the project teams and move on to the construction project. So the teams we have on the west are made up from select military staff, staff from other railway disciplines, whether it's internal or external, and we have some new staff which we've trained up as operatives and technicians. You can see the photographs there where the team is busily changing out a Tensivex unit as part of some of the pit stop training. Thanks very much, Elena. So it's not been as easy as to go out and get a team of linesmen or women to come in and create a maintenance team. You have to sort of progressively build them up. So that's just a snapshot of the competencies which are required to sort of come in and maintain your Redline, both mechanical competencies and competencies to enable to switch the Redline in order to take an isolation. And I guess it's not too dissimilar to track, because there's a set of competencies, there's longer arm in order to do track maintenance, unlike there is for track renewal. So we're very much in the same boat. But there's quite a lot to get through to get a team up to manage the Redline sort of 24/7. And actually we do maintenance. We do maintenance work. We do some snagging work for the project. And also we provide isolations for other disciplines. Thanks, Elena. Okay, again, similarly with the permanent way, Redline is no different. It's got some manual inspections and it's got some dynamic inspections. Perhaps track is a bit more sophisticated in the world of ultrasonics. But we still use measurement trains. So if we look, we still do traditional foot patrols. They want typically on a 3-monthly frequency. A high level intrusive could be a 4 yearly or a 6 yearly, depending on where we are and what type of asset it is. We do an early failure inspection, which is quite an intrusive inspection, which is to take off some components, and have a good look at them, and look for early signs of wear. Need on some components, look for signs of cracks and the metal fatigue. So we've done quite a lot of what we call level A inspections, and that's given us a view of what we need to manage, of the detail we need to manage, and there's been some good findings from that. Asset condition inspections, they're very much based on wire wear, and then we do dynamic inspections. So most of you will be familiar from the P-way that we've got the new measurement train, the NMT. On top of the NMT, there's a set of lasers which that will record the overhead line. So that will take height, contact wire height and stagger. It's non-contact, but it does take height and stagger. And then we also have the mental train, which that will measure contact force, height and stagger, and a couple of other bits and pieces. So the mental trains run on a 12-monthly frequency, and the NMT runs at the same frequency as it does for the P-way. So more recently, just touching on inspections, we've used. Lost the screen. Okay, we're back. Thank you. So more recently, we've used camera on a pole. So traditionally, we would need to go up in the basket to do some inspections. If we've got a discrete inspection, we can use a GoPro on the end of an insulated pole, which is very good for taking a snapshot of an inline component, and we can look at the top trains. If we need to, we can look at switches and clamps and brackets. Thermal imaging is useful. You can see this is the network rail helicopter with its the imaging camera turned on. That's if you look in the centre of the photograph, X marks the spot. That's a hook and eye arrangement, which as you can see is very hot. And in fact, that hook and eye arrangement did burn. So it is thermal imaging camera is useful to give a large sweep of the network. We don't find any defects, but when we do, it's very useful. And more recently, drone technology has been trialled. And I think it's been trialled across the network rail network. I think it can give a good overview should we have a derailment. You can get quite close to things before we've got boots or ballasts are very good for quantifying damage. It can be used for other disciplines, as we know. For instance, if we need to get out and have a look at a bank slip or vegetation management or anything else, particularly useful for flooding. So drones have a place in the toolbox. Thermal imaging camera, and there's a whole host of whether that's some bolts in terms of tools which we use during the toolbox. Okay, and then so pantograph video footage is good, as we said a moment ago. We've got pantograph cameras in most of the trains, so very good for replaying incidents and getting the view of the health of the asset. If the pantographs are damaged, then that tends to mean that the asset is running okay. And we'll more on that in a few minutes. And then we do some sort of ancillary equipment inspections, which are on different frequencies. So magnet bonding inspections and height and stagger inspections. Next slide, please. Okay, thank you. And again, what can go wrong? Okay, thank you. Birds are a big one, and probably the cause of a significant amount of overhead line clippings or short circuits. The protection system cuts in. You can see this was down in Newbury only a couple of months ago. The bird was caught on camera, so there was an overhead line trip. The team were notified by the distance to fault. We went to have a look at the bridge. We found a pigeon. Then we interrogated the train. The pantograph video footage you can see caught on camera, and that was a problem. That is a problem. The photograph on the top right is a seagull, which has got snagged in the pantograph, and then the photograph on the bottom right was a pigeon which straddled an insulator between the line and the dead section, got electrocuted, and then fell onto the bank and set the bank alight. So birds are a constant problem and a constant source of overhead line clippings. Vegetation, this picture on the left is courtesy of Simon Warren. Vegetation management is a challenge. We have to do it, but it is a challenge because there's so much of it. So if you look at the photograph on the left, you can see a nice profile there of probably what is akin to a shipping container, and the vegetation goes up towards a contact wire in the pantograph area. If you look at the photographs on the right, whilst they're a bit dark, you will see that on an approach to a bridge, we've got a pantograph. It picks up some vegetation, carries it into the bridge, and then shorts out between the vegetation on the pantograph and the overhead line system inside the bridge. That was done at Ealing Broadway. So vegetation management, even in the suburban areas where you think you haven't got much vegetation, it does tend to poke up and around bridges, and we work closely with, once vegetation is off-track matter, if it comes in within our envelope, we will cut it back, and there's a synergy between overhead line, off-track, and our friends in structures where what we need is we can cut it back. The vegetation teams can take the tree away, but quite often you need to take that tree or the roots of the tree or the plant bush out of the infrastructure. So that could well be digging it out of a brick arch bridge. So structures need to, we ask the structures to dig it out, cut it out, and make good the brickwork so it doesn't go back. So it needs to be very joined up, otherwise 5 years down the line we'll be back where we were. But so vegetation is a challenge, and we've had a few issues. Next slide, please. Okay, thank you. So extreme weather, and this is something which is caught the industry out. I'm sure not caught, nothing fair to say, is a challenge to the industry. So we know it's a problem for track drainage, earthworks, and extreme weather is a problem for overhead line, whether that's extremely cold weather with wet tunnels or extremely hot weather with fixed tension equipment. But this slide is really about wind. We last week, a couple of weeks ago, there was trampolines, greenhouses, polythene sheets on the overhead line, gazebos, you name it. Things do get picked up in the high wind, and the climate, as we all know, has changed. That's problematic with third party items coming onto the infrastructure. The photograph on the bottom left is an umbrella which was blown into somebody's hand in Paddington, made its way down off the bridge and shorted out on top of the pantograph, which is the picture on the bottom right. And then we can see with the photograph of the train, that's a third-party tree coming through the infrastructure, taking the cantilever wire down. Again, problematic. And the photograph on the right, that was a major incident. Again, a third-party tree coming through the boundary fence down onto the overhead line. Thank you, Elena. Okay, so we've spoken about the weather, which is what we like to do, and we've spoken about birds. So the other, I guess the three things: birds, the weather, and sort of defects and snags and components which wear out, for want of a better word. So if we touch on sort of construction, there's a photograph on the left where we've got a broken dropper. It's parted midway between the contact wire and the catenary, and the bottom end of the dropper is dropped on itself, and is then fouled on the pantograph gauge. Now, not strictly a construction defect, but on metallurgical examination, the cause of the corrosion in the copper wire was down to chlorine and chlorine ions from diesel fumes. It just happened to be this location was in Slough, Maine, where some training would stop, and it was contaminated by, let's say, chlorine ions. When we took it into the lab, we benchmarked it against new copper wire, new dropper wire, and there wasn't a problem. So not a construction defect, but nevertheless a bit of a challenge and significant train delays. The photograph in the middle there with that column, that mast, is where we had an over-tension earth wire. So similar to track, if we don't put it in the right temperature, we don't put the rail in the right temperature, or we don't stress it, you either have a problem when it gets very hot or very cold, and that's what happened in this case. This wire snapped at -8. The system design range is circa -18. So this earth wire had a huge amount of load on it, and it snapped. So a bit of work to be done to reset earth wires, which leads towards sort of more of a construction issue. Then the photograph at the bottom left is one we looked at earlier on. That's a hot spot where there's an issue with some of the jumpering in there. We think that was a bit of a change in some of the upgrade work. So there's a bit of work to do on that one. And then we photograph on the right, we touched on earlier on, that again, that was, believe it or not, an incorrect torque setting applied to a new type of clamp. It looks the same as any other clamp, but it isn't. It was the torque sequence was different. And if you don't do it to the sequence, it'll fall off, which indeed it did. We've since gone out and checked all the other clamps, and it was just very much a one-off. But so that's a flavour of some of the snags we've had. Next slide, please. So, like any big system, where we've got lots of nuts and bolts, if you look at the old Redline system, there's tens of thousands, probably 20,000 insulators, tens of thousands of droppers, and lots of ancillary components. So, things do go wrong, and we've not had many failures. I think in the grand scheme of things, it's been very good, but we've had a few, and it's the typical bathtub curve where things go wrong at the start. There's some aggressive contact wire where bits fall off. It'll settle down. We do a little bit of midlife sort of campaign change work, or tighten up, and we do stuff on our B13 inspections, and then we will then, towards the end of the asset life, which is probably circa 80 years, it'll probably start to require a bit more work. So we're very much in the burn-in period, for want of a better word, coming through it, and we've not had too many failures given the amount of overhead line. Because the biggest challenge at the moment is birds in the wind. Okay, next slide, please. I think Elena's going to run us through briefly on pantograph monitoring systems, and the first thing that the route director said to me when we talked about finding a defect, he said you can't even find the haystack, never mind the needle. So I'll just leave you with that thought. Thank you.
Thank you, Darrel. So I'm going to talk in the next slides about pantograph monitoring systems. Existing or obsolete pantographs monitoring on network rail areas. So we had a legacy system known as PanCheck, which was measuring the contact wire uplift and the associated parameters, and that was installed in 1990s, and now it's obsolete. At the moment, we have in Scotland PanMon 2, provided by Ricardo Rail, and is installed at 7 locations, and it's incorporating 16 scanners. The picture on the right, you can see what is now installed in Hinland Station in Scotland. Pantobot 3D is provided by Camlin, and it's a system which is installed at Heathrow since October 2018 as a wayside option. On the next slides, I'm going to talk about wayside option and as well mounted on the boom. So the system is managed and is maintained by Network Rail, and presently at the moment we are reviewing this product for product acceptance on Network Rail infrastructure. At the bottom you can see the 2 pictures with the installation. We have wayside, as I said, at Heathrow. In this slide sorry, just pause again. In this slide, you can see some anomalies which were picked up and identified at Heathrow. The left picture, this shows a horn damage, and the right one, it shows a carbon chip. It's a picture, and at the bottom is the 3D model, which is provided by Pantobot 3D. So as I said, we decided to have Pantobot 3D installed in Western Route. At the bottom you can see the 6 location, which was like strategically choose to install Pantobot, and an example is monitoring the border from Crossrail and Western Route at Westbourne Park, and as well between Wells and Bristol at Severn Tunnel. Severn Tunnel. So our installation is going to be on overhead mounting frame, and you can see the picture at the top. It's what we had as a trial installation in the Swindon Training Centre. So with the introduction of the new timetable to facilitate the cross-rail and introduction of the IET trains, there will be an increase in asset utilization and wear, of course, and understanding how the infrastructure is performing is vital. So as you can see in the graph, the number of pantograph passes has gone up since 2013 for the relief lines and main lines. And with so many train operators and so many trucks to cover, it became vital to install a system to monitor the pantographs, because this way it's quickly to identify any faults. So Pantobot 3D, I'm going to talk a little bit just to give you an overview on Pantobot 3D system. As I said, this system is it is designed to provide in real time pantograph condition and assist in early identification of the root cause and of course the location of the damaged pantographs. That's going to give network rail and the train operators some details on the pantographs which are outside operational limits. And this system is going to be installed and commissioned by Network Rail Capital Delivery. On the bottom left, you can see the Pantobot 3D wayside, which is installed at Heathrow, and as far as I know, in Italy. And on the right, you can see a Pantobot 3D overhead mounting frame, which is going to be installed in Wales and Western. These are some key features of Pantobot system. So it's fully automated alerts notification. It's going to recognize and classify the pantograph, which is very important. It's going to identify the missing or damaged horns, chipped carbon strips, any objects in the panwell, carbon strip wear, and a lower high uplift. And on the picture at the bottom, so when the train crosses the section, the side of the train is going to be completely scanned, and the high definition image is going to be provided. So the position containing the ID code will be automatically identified and associated to the event, which is very important. If we have any problem, we need to be able to identify which pantograph is the problem. You can see here, so we have a user interface, which is called Pantobot Pro. And you can see this is an example from Heathrow, where the pantograph alarm on the carbon wear, you can see it's gonna, so this interface, it's providing a picture, and then you will get a red alarm or yellow. It depends like what are the settings of the system. And you can see a 3D model of the carbon strips, where it's like actually it's pointing where the problem is with the pantograph or with the carbon strip. And on the left, you can see there are a number of like filters you can, so you can change different things and ask for like a date of like a certain incident or and so on. I'm going to talk a little bit on OLE and pantograph image recognition, which is another system which soon we're going to have this in place. So this is a journey, a joint journey, I could say, between GWR, Network Rail, Oxford University, and Incremental, and this project is led by GWR. So this is like high definition pan camera, which at the moment is fitted on a GWR class 387 trains. And this system is going to give Network Rail a number of benefits, which is going to be, so this system is going to be able to monitor the infrastructure for any degradation or defects, which is going to help us to optimize the maintenance. and of course it's going to reduce the track walk. And for train operators, it's going to detect the pan defects, including the pan flips, which have caused lots of safety issues with the wires down. Because it's like a defective pan, as we know what we learned from the past, it can run for long distances without being detected. So our mission is to predict and prevent. So we are looking to decrease the time taken to investigate failures. We want to avoid disruption to train services. We have the option of including statistical and trending analysis to save the time and cost of preparing the report, and railway operators to make informative decisions. Before I go to question and answers, what I want to highlight is like future work for us is intelligent infrastructure integration of Pantobot 3D and OLE through the common dashboard tool, which at the moment is in process of being developed by Network Rail. Thank you.
Thank you. Okay, thanks very much.
There is no question yet in the chat box, but I have a question to ask. Elena mentioned this correlation with the intelligent infrastructure project. Will that be looking into correlating the overhead line irregularities with the irregularities of the track in any way, and how will those be managed? If there is any information on that, would be interesting to know and discuss here.
Darrel, will you be able to comment on that?
Yes, well, there is a system we have now which is called LADS, which is Linear Asset Decision Support Tool, and that you can bring up data. So if you have an overhead line fault, similarly to track, if the NNT recording train identifies a fault, you can look at in decision support tool. You can look at that data. You can look at the trace. If there's a geometry fault, you can bring up on a different channel the overhead line position or the stagger. So you can bring the two together. That is not automated, but I think there's an aspiration to bring that data together. But the data is there. That's at the moment in the decision support tool that you have to manually sort of bring that data up there. It doesn't tell you that you've got an overhead line fault, and by the way, it's caused by the track. But if you had an excessive stagger, well, we do have locations where the count drops off, and then the stagger goes outside its limit. You'd be able to see on the track trace what's happened to the count of that location based on the previous runs. Does that go somewhere to answer the question?
Yes, yeah. Simon Warren has two questions. Simon, you can ask them directly if you unmute yourself.
Okay, that helps. Thanks, Darrel and Elena. That was great.
Okay.
I've got two questions. The first is more: do you think it would help future maintenance if some of the maintainers were brought on early as part of the projects to help as construction managers and supervisors, so they can see the asset being built and report problems and understand problems and what they're getting from the start, and then hand it over? Obviously, that can't happen for the project that's completed, but it would be going forward.
Yes, yes. When do I start? Yes, but just sort of cut in there, Simon. Yes, I would very much, if that should be encouraged. I think it's an opportunity we didn't realise at the time. Yeah, I think it should be.
Yeah, and it's then how incentivising people to go and do that, and as a little route into the maintenance as a longer term employment route, maybe. Yes,
it's difficult. I'm sure contractually the things would be different on one side of the fence compared to the other. But I think I think the idea is correct, and I know even when I look back, I feel I didn't spend any near as much time out as I should have done. I feel that was an opportunity missed. Every time we do go out, you always learn a lot. So yeah, you're right. I think we should do that, and as a company for Network Rail, we should do that. And even and particularly, we see it. Sorry to cut in, but on the Midland Main Line, as we electrify it from up through Kettering South and up to Market Harbour and into Leicester and so on. There's an opportunity there, isn't there?
Yes, I think so. Yeah. So,
oh, sorry, Simon. I apologise. Carry on.
Okay. Sorry, and my other question was with the alert system. What's the frequency of the pan cam footage, and how is that? How does the system get over that frequency issue between two images, and how much movement? Obviously, a pantograph between that time frame could move a little bit, whereby some of it is right at the end of the time between the two photos, or it could be progressive over the lot.
I'm not sure. That's probably one for GWR, an incremental assignment. I'm not sure I can. Are we talking about the a repeat run? Is that what we're talking about?
No. So from what I understand, it compares the two images, and then the difference in the plunger or head location different. Yes. Okay. So between those two images that are taken, say at 60 hertz, say,
yes,
the pantograph could move progressively between those two images, which is fine. Alternatively, it could be fairly static, and then just before the second image is taken, it moves significantly.
Yes, I understand the question. I'm not sure I got the answer.
Okay, well, sorry.
That's okay. That's something we can. I've got your number, as it were.
Yes, okay.
So we can certainly take that back to our friends in GWR who are a bit closer to the coalface on that project.
Okay, thank you.
Yeah.
Hi, Darrell. I'm Stuart from Network Rail. Sorry if I'm butting in. I can't see any questions. Oh, there's one there. I just got a question to you both. Of the work you're doing on pantograph monitoring and wear and stuff like that, how much of it is going to be fed back into the kind of the maintenance manuals for Series 1 and even UKMS? Is there sort of going to be lessons learned from what you're doing?
Well, we'll certainly be able to benchmark pantograph wear, and in terms of we have trains which shuttle back and forth to Heathrow, and they shuttle back and forth on a Mark 3B legacy system, and then we have trains which spend most of their time on the Series 1. So we will have different data sets which can inform future designs of all Redline systems. But is everything formally in place? I think the answer to that is no, but obviously we're happy to share that with any design team.
Okay, great.
Yep.
There is another question from Colin Dent. Does all the existing OLE equipment comply with the present fault current requirements?
So could you just repeat that one? I got most of it, but could you just repeat that one, please?
Does all the existing OLE equipment comply with the present fault current requirements?
Well, there's been a system upgrade, so there's been a number of modifications So there's a number of when we look at the increase in train usage and current draw, there's been a campaign change to take out certain components and the 12K power upgrade. So there's been quite a bit of work done to make the legacy system more resilient. And for example, current carrying droppers will be one. The stainless steel droppers and having current carrying droppers will be one example of a few.
Sorry, do you want me to jump in there, Darrel? The series one is has got a 12 kA fault current rating, and the Mark 3B on 0 to 12 is, as Darrel says, being upgraded to account for it. But the fault current isn't yet. It's only operating at 6 kA fault current currently until that upgrade's complete.
Thank you, Simon. Yeah.
We have another question from Jeff Hancocks. Why are pan cameras not mounted at the entrance to depots? And what is the action for a red flag, stop the train? I recall at King's Cross there is a camera for the pans. Why is Network Rail accountable for their operation on the Western?
Well, the train operators do. It actually do have a pantograph monitoring system in their depot. I forget the name. It's an Australian system, and that does check pantographs in and out. The importance of monitoring pantographs is small, even a small little bit of damage on a pan. If that's left unchecked, can cause quite a bit of damage in a relatively short amount of time on the network. And we've had some unfortunate instances on the Heathrow line where there was a rural pantograph going around taking out droppers. So we ended up having 100 droppers off, and nobody knew about it until the train was inspected at night. But they do, so TOCs do look at their pantographs, and they have a set of inspection frequencies. Some of the train operating companies check theirs on time. Some of them check on mileage covered, but most are now checking them daily. When they do that, they put the train through a laser scanner, and it does take some pretty basic dimensions of the pantograph carbons. And in terms of the alarms, there is a series of alarms, and in principle, so they're red, amber, green. Elena, perhaps will give us a bit of a talk through on the alarm arrangement we're looking to implement regarding pantograph monitoring.
So we are going to have 3 types of alarms, which is going to be level 1, 2, and 3. Is like green, amber, and red. The green one is going to be more an alert, I would call it, and it's just for us. We are only going to collect all the data from the Pantobot, so we can create a kind of like trending of the carbon wears and so on. We will have a number alert, which is going to give to the talks sometimes to plan maintenance ahead. So depending on the threshold, we decided to have, they might have a week, a month or so to plan the maintenance. And on the red ones, it's actually an alert that's going to go in the control room, and it's going to be sent to the talks and our maintenance team, and it's for someone to actually action that when the red alert is received.
Just one point to add. I think with having multiple train operating companies running around in sort of east of Reading, but when we do have an alarm, it's important to know, we very quickly need to know where that train has been, and we can find that, and then how many trains are damaged, and how, within that particular fleet, is it one Is it the whole fleet which is running around that mooring? Is the problem isolated to one particular line? So by having visibility of pantograph condition, and if we do get damage, how much damage we've got, it can allow us to sort of drill down quickly into the fleet and into the line where that train has been very quickly. In old money, if we had a problem, we would be checking every train. We'd put staff on bridges looking down. We'd put people out running around depots, and we haven't got the resources to do that either. But when we're looking for something the size of your fingernail, chipping away at a pantograph, and the chips just get bigger and bigger and bigger, we need to react quite quickly when something's gone wrong.
Okay, thank you. We are a bit beyond the limit of the meeting, but there is one last question in the list here from Paul Townsend. Were any surge arresters installed on the Western Wales OLE system? If so, do they present any particular maintenance challenges?
Not on. I think there was some in the Wales section for low clearances, but on between Paddington and the border on the western route, no.
Okay. Thank you, Elena and Darren, for presenting today. I have one last announcement for the members of the PWI. Next week we will be sending by email a link to a questionnaire, a very brief one. Will take less than a minute to respond, to ask for your feedback with regards to the meetings and with what the Western section of PWI can help you with in your professional development. Again, thank you all for attending the meeting today. See you in October.
Thanks very much. Thank you all.
Thank you.
Bye.
Yep.
Thank you, everyone.
You're welcome.